Let me give a warm welcome to everybody here. So I'm very happy to see everyone at our next and this data science seminar. So this series of seminars are organized already since, a couple of years ago at the Institute, more. And they happen every 2 months. This one is dedicated to AI. So AI is almost absolutely everywhere. And if I manage to squeeze in some self-promo, then of course AI is dealt with in this building as well. And although we could use some more funding for the education and the working and some more rooms and so on, this is beside the topic today, so we will not talk about this. What we will talk about is that AI doesn't cover every area equally. Rather, it has proliferated quite successfully in text processing, and I think the big boom started with DALL-E, so 2.5 years ago or so, with image generating. And if you look at the slide, then, that's, I guess, a nice enough illustration that now we generate images, not just look for them on stocks. But how about all the other areas? So speech, motion, and even the areas the AI stuff covers aren't really, always production ready. So this is exactly what our today's seminar is dedicated to. We have people from Zurich and Texas and even from Tallinn. It's sometimes hard to get them here, but we are very happy that everybody came. And we have, the schedule is in front of you. We have sign language processing, we have speech processing and speaker identification and processing. We have LLMs in production, and we have robotics and controlling robots with LLMs. So after all of this, we have the panel, and here is something I wanted everyone to remember, that even though everybody from the schedule here came with their own prepared topics, you, the listeners, you, the participants, don't look at it as you're listening to this topic. Look at this as your chance to prepare the questions that have been eating at you on the topic of handling motion with AI or with text or sign language processing or anything to do with speech, anything to do with robotics or LLMs in production, because this is your chance to actually ask those questions. So we have assembled a team of 5 brilliant people who are great experts at these areas, and even though they will talk on the topics that they have prepared, you get to ask them in those areas much more widely. So enjoy, prepare questions, and I will now invite our first speaker, who is Amit Moryossef from the startup company sign.mt, has a PhD from Zurich, has worked in Google before, and before I give away all of his introductory slides, I'll just invite him here. So,
perfect. Thank you very much, Mark. Test, can anybody hear me? Wonderful. All right, so hi everyone. My name is Amit. I'm presenting about sign language. Until 5 minutes ago, I didn't really know what's the background of this audience, so I prepared slides for technology-oriented, linguistic-oriented. Luckily, Mark just mentioned that everybody here should have some touch in IT. Sign languages. Sign languages are the primary means of communication for deaf people worldwide. There are more than 200 sign languages here in Estonia. There is Estonian sign language. Fun fact, I learned this yesterday, the sign for Estonia in Estonian sign languages. This, I don't know what it means to you, but take it as you will. It's actually also the same sign in Swiss German. I come from Switzerland. I want to say I come from Switzerland. I come from Israel, but I live in Switzerland. In Switzerland, we have 3 official spoken languages. We have 4 national ones. We have Swiss German, Swiss French, Swiss Italian, and then we have the same for sign languages. So we have the Swiss German Sign Language, the Swiss French Sign Language, and the Swiss Italian Sign Language. The Swiss, like the Swiss, they just like doing dialects of their neighboring countries, so the Swiss Italian Sign Language is actually a dialect of Italian Sign Language. Swiss French Sign Language is actually a dialect of French Sign Language, and Swiss German Sign Language is also actually a dialect of French Sign Language for some reason. They also love doing dialects, so there's 6 distinct dialects of Swiss German, including one that is Liechtenstein Swiss German Sign Language. Very confusing. This is how sign language looks like. We have a visual input where we have a person performing movement with their hands, face, and body. And what we see people doing in research and in companies is trying to develop translation systems. They would like to create systems where we either write some text in this case, English, and we want to translate it to American Sign Language, and we were able to generate an output in a video. Or vice versa. We want to give a video, and for the system to tell us what is being signed in a spoken language. This has many implications, such as on trains, on online videos, such as YouTube with 1 speaker, Netflix with 2 speakers, online calls, conferencing calls. So we have here a Zoom call where we have a fake interpreter, AR, VR, mixed reality, you name it. Lots of options. And the current state of existing sign language translation technology is nothing. Last year, 2 big EU projects were concluded with these budgets, where both projects were assuming to, in 4 years, solve sign language translation for 20 European sign languages. Unfortunately, the output of both projects is nothing. They said everything will be open source, and they said everything will be great, and we'll have tools, and the deaf people will have accessibility everywhere. That is not the case. There's now another tender for here in Estonia. Hopefully, fingers crossed for Mark to get that and solve Estonian Sign Language. That leads us to my PhD thesis, where I'm trying to develop a new paradigm on how to perform sign language translation and sign language processing. Anybody know who George Hotz is? All right, we got a couple. That's sometimes better than other rooms. He said this last year, and I really like the quote. He says, "The hard part of programming is finding the right way to factorize the problem. The rest is fill in the blank." We have a huge problem here to translate between videos of one language into speech in another language, and we need to find a way to bridge that gap. So what factors do we have for sign language? We start with a sign language video. This is a video, an example video of American Sign Language, a sentence. She is signing your name, what? And that is translated to what is your name? We have this video stream, and some possible factors that we can perform are pose estimation. Poses are a way to identify where every joint of the body is, where the shoulders are, where the hands are, where each joint of the hand. We also have a way to write down sign language. There is a system called sign writing that allows us to phonetically write the sign language. We'll look at the example. I learned that this is really cool. Oh my God, this works. Okay, we have an example here where we have this shape and an arrow. What this means is that we have this hand shape, and the hand just goes forward. We're able to write down the different phonemes and characteristics of sign language as text. There are other systems like this one called Hamnosis, but it's really hard to read, so nah. And then, of course, we also have a way to represent sign languages as glosses. Glosses are a way to write down the meaning of each sign in a unique identifier. Like I signed before, and I said the first sign is a sign for your, the second sign is a sign for name, and the third one is for what. But it doesn't take into account the entire language. Only part of the language can be described this way. For sign writing, here is an example of a construction of a sign. This sign here on the right has many, many phenomena here. We have, if you look at me, the way that we actually produce the sign is this, who. And the sign is who in American Sign Language. It's a question sign where we have the eyebrows being going down, the mouth being wrinkled like we're doing with our mouth, as well as we have one hand, which is the right hand, which is using a trigger finger, which is rotated like this and is placed on the chin and is being squeezed. Sign language is very complex and allows us to use one syllable with many, many different morphemes. And so we're able to write down the signs in this way. I started with this as an intuition, and then 4 years ago in my childhood bedroom, I did some experiments with pose estimation and then with writing, and saw that it is indeed possible to take videos and write them in discrete units of sign writing. Therefore, in theory, what I'm proposing is that I know this seminar is called Beyond Text or something, but what I'm actually proposing is going back to text. I'm proposing that we take the sign language videos and we write them down. And once we have them written down, we'll be able to translate between a written notation of sign language, called sign writing, into a spoken language notation, such as English. We have some text in the second line, we have some text in the third line, just normal language model. This is the theory, and indeed, in practice, it works. So my affiliations are both a postdoc at the University of Zurich and CTO of my own company called sign.mt. This is real. Our technology shows that we can take the video from before, we can segment the signs. We can say there are 3 signs. You can see like blue lines around somewhere. Then for each sign, we can transcribe that sign in sign writing. And finally, we can take the entire sentence, segment the sentence, and translate it from text in sign language to text in spoken language. All this works right now. Looking at the time, okay, let's do a funny video. Can we play this? Would that be working? Okay, that opens, great. So if we can do sign writing, we can't only do sign languages. We can also do spoken languages that use gestures. Here's a video in Napolitan where people are just trying to gossip, and all of the movements written down. Thank you, we can go back to the slides. Okay, so with sign writing, we can also enrich spoken languages and include co-speech gestures and other articulations of the body that are not just the audio signal. Now, to go a little more in depth, I showed you what works. Let's look at the other direction and show how we actually make things work in practice. This is not just research where we can make a model and assume that we have clean input from every user. It's actually a dirty world with many stupid people. And so we have to take all of that into account. We start with doing speech to text. That's quite easy, and let's say, to some extent, to some languages, don't kill me Estonia, a solved problem. Then we can do language identification. Now that we have text, we can say, okay, someone just wrote a German sentence, but chose the English language to translate. Our models will not be robust to it, and so we should correct for it. Then someone else wrote many grammar mistakes and input errors in their text, and we would like to get clean, nice text. Luckily, we have language models that are able to just perform. Finally, now we have nice text, and I will not let you on with more annoying steps that we have to do. We can perform translations. We take the sentence from before, what is your name? And we translate it into sign language text, in this case in American Sign Language, in sign writing like I showed before. Given that we have the signs, we can use a motion diffusion model that takes sign writing and generates a sequence of poses, so these skeletons like before, that are able to reproduce the motion maybe if I go one back, we saw we have this sign here, we give that to the model, and the model just produced move hand forward. Very nice. We're then able to also generate videos. Here is a terrible, terrible GAN from 2017 that runs directly in the browser that tries to mimic a human. We're way past that with current AI technology, and no, yeah, okay, I think this is the last one. We can do a lot better, and we can even do a lot better than this. But anyway, we have tools to make the videos look like a person. We also have ways to make the video look like an animated character. Unfortunately, when showing this to deaf people, they're a little skeptical. They are concerned about these characters. These characters don't really mimic humanity, and then they can't fully represent sign language unless they look fully human. So I'll go back to the goal of existing sign language works. We want a translation model that takes some text and translates it into sign language, and that is something that we have at sign.mt. You can all open that on your laptops if you want. You can enter some text, in this case German, translating to Swiss German, and we're able to translate into sign language. The pipeline is actually a little more complex than what I showed before, but it's the same basic principles. Another slide about sign.mt that I forgot it is here. Some PR, okay? So we have tens of thousands of people using the websites per month, coming from all over the world. The project is completely open source, so you can go on GitHub and play with it if you want to use on your laptop without me tracking your analytics. We have pipelines to translate between sign language and spoken language, and vice versa. And one bonus pipeline that a tender that now exists in Germany is sign language anonymization. I feel like, to some extent, I lost the room. So let me just go one back here. These pipelines, they are, every single edge of this pipeline is research work of a student, a PhD, or just years of collecting data and building models. It's a lot of work, and a lot of it is necessary for people like you to participate in. I honestly don't believe that a project that said, here's 4 million euros, let's solve sign language, can actually solve it, because we have all these steps. But now that these steps are all open source, we can actually, let's say, solve it to some extent together. I'll skip here and just say that we have many, many tools open source. We have a lot of research that we give background to at research.sign.mt. And then we have a lot of open source utilities that we developed, such as pose format, a utility that allows us to work with these skeletal poses. Sign language dataset, a utility that allows us to work directly with different datasets with just a load command. Unfortunately, sign language datasets are huge. We have long videos of people signing in high quality, sometimes in low quality, hopefully in high quality, and so we need some way to host everything and to load everything. We have a utility to work with sign writing. Sign writing, the writing system that I showed you all, is not necessarily the most trivial thing to work with. We have different representations of it, both in ASCII and in Unicode, and so utilities to work with it are necessary. This was a fun project. We have a utility that can take sign writing and say, actually, people can't really read this, like deaf people can, but you all probably can't if I just show you one sign. So how about we try to use models to take sign writing and generate a picture out of it. That one you can all read and you can understand what it means. Similarly, we can take sign writing and describe it. We can tell you, touch your dominant hand open to your lips, then move your hand forward, palm up. That is the sign for thank you. We have a vector quantization model, sign.vq. Sign.vq takes a sequence of signs, sequence of poses, and discretizes them into sequences of tokens that language models and the like can work with. We have data sets that have sign writing parallel with spoken language, such as SignBank Plus and even others, that show that when we then perform translation, even with models from scratch, we can achieve decent blue scores, such as 28 or 30 something. We have evaluation utilities, we have benchmarks, and finally we have a tool to perform data annotation, such as alignment of captions and writing of the sign writing for the videos. This work could not have been possible without these people, including PhD advisor, including my postdoc advisor, and many others who I have collaborated with over the years. And I guess, thank you all. I'll be ready for questions.
Thank you very much.
Before I take the questions, I did make 50 slides, and that worked in 17 minutes. Okay, go on.
Cool. So, do we have questions?
We have one right there.
So thank you for the talk, but like a profane in this area. So you might think that you don't need the sign language, right? Because nowadays we can translate directly from the video to text and vice versa. So can you work at the level of frames without having the intermediate representation, which is the sign language? Or don't you have enough data to do that? Well, what would be the problem with this approach?
Give me one more slide. Yes. Okay. So what you're suggesting is that we go directly from, let's say, the video stream, to the spoken language. What is your name that is written there at the top?
Yeah,
correct?
Exactly. That's it. Yes.
Great. So in theory, nothing is stopping us from going in that approach. In practice, there's just not enough data. So the largest data set that exists contains 7,000 hours of sign language, which sounds like a lot. 7,000 hours of sign language is 2 million sentences, and that is nothing compared to any machine translation task. Those 2 million sentences are distributed among 25 different languages, and so we basically don't have enough data to learn how to translate any person with even, let's say, noise to the correct spoken language sentence.
So that's why you need the intermediate language, because in principle, if you have enough data, you could solve the problem like this, right? End to end. I mean, in principle.
Exactly. In principle, same as we see in the spoken language, in speech. Before we had a lot of data, we used a lot of pipelines. And now that we can generate a lot of data and we can collect a lot of data, we perform end to end because we can do large scale pre-trainings. This will happen too here. I don't believe that this approach will last in 10 years, maybe not even in 5. But for now, this is what we need to make that step towards the end-to-end models.
Okay, thank you.
More questions?
Thank you, very interesting. So what are the kind of main remaining research challenges that you see there? You could almost, from your presentation, think that maybe almost everything is solved. It's now a matter of a bit of kind of technology to put together things and then it's done? Or are there many challenges ahead?
That is a great question. Let's go to maybe the pipelines, see what we can say about that. Okay, so we have 2 pipelines, 2 directions. You can see that I'm trying to color the arrows to some extent and show you that everything that is red does not really perform well. Everything that is yellow is like decent enough, and everything that is green is perfect. We don't need any further development. You can see that there is a lot of red and yellow. The reason for all of the reds is mostly technical. There's a lot of implementation necessary, a lot of inference that is required, especially on device. The yellow ones usually, let's say, work in laboratory settings. If we have a very slow, standing straight person performing, let's say, robotic sign language, that would work. If we have a person in front of their laptop with their lighting, who knows what setup, we don't necessarily think that works right now. And so we need a lot more robustness, more data, and frankly, even better code. Like all of these were projects, they were proven to work to some extent, but we just need more. Thank you.
I had a... Oh, there's more. I'll give priority.
So you've mentioned how you received the feedback about the animated person showing the sign languages. So I was wondering, how do you actually receive feedback? Do you over time like gather some data and then show it to some subset of people, or do you have like employed people or like dev developers who can give this feedback immediately?
Yeah, so the way that we get feedback right now for our models and for different approaches is two. One, we work with deaf researchers from the, wow, how do you translate to English? University of Teaching? University of Pedagogics in Switzerland. They have like a couple of deaf professors where we consult with them, we show them different things that we are working on. And they're like, oh, this is, no. Or, oh, I guess this one is a little better. And then that's how we advance. But once we actually have a solution that we want to deploy, we first deploy it in front of deaf people, mostly in Switzerland, I will say, specifically for Swiss German, Swiss French, and Swiss Italian. Usually studies involve 5 people per language pair. It's very hard to recruit participants for these kind of studies. And then they compare whatever we have to a human translator and see what is the results, both quantitatively for quality of the translation and both qualitatively. It was weird that for a second there was 6 fingers and not 5, and or the fingers mashed into each other, and I got the creeps. And so we get feedback from both the direct users and experts.
Thank you.
Thank you. In Estonia, at least, the sign language was made very popular from the music point of view. Eurovision performers have been sign languaged.
Mm-hmm.
So that brings me to the question: so how do you add emotions and these kinds of music? And have you considered something on that front, sort of like music? Because then it's really like a performance, mm-hmm. and very emotional as well.
Yeah. Okay. First of all, that's a great question. The way that I got into sign language is actually through the Eurovision as well. I got there around May 2019. The Eurovision was in Israel. A friend of mine who is a sign language interpreter and I were sitting in the car. I asked her, what software do you use to translate? She said, nothing, and here we are. Translating music or any art is very difficult, even between spoken languages. I give you a song in English, try to translate it to Estonian. I would imagine it would lose a lot of meaning, a lot of deep meaning, a lot of like between the lines, maybe rhyming. It will lose a lot. Specifically here for sign language, it's to some extent the same, but with our pipeline, when we want to write sign language, we can even write when someone is singing. So if someone or performing a song, someone is performing a song, we write their movements. Then we could have parallel data between the writing of the movements of the song and the spoken text of the song. We give all of this to the model, and the model decides what to do with it. I don't think that we're really advancing to building now art translation. Thank you for your question.
It does not need to be real time. It can be really slowly processed as well.
Yeah, I think it's still the same thing. If we want to translate now a song from English to Estonian, Google Translate doesn't work, or maybe ChatGPT will do better, but still we will struggle with translating art. It is possible. Humans do it, so it's clearly possible. But I would not focus on the development of that technology. That is my time. Thank you all very much again. And I will leave to Mark to continue.
Thanks a lot. We're a bit ahead of schedule, but sure, let's leave all the other questions for afterwards. But meanwhile, and we are switching to Joonas Kalda, who is currently almost done with upgrading his master's from Cambridge into a PhD from TalTech. And the rest I give to him. Joonas, floor is yours.
Thank you. So hi everyone, I'll be talking about our work on multi-talker speech processing. So first of all, what are the applications? Why should we even care about this task? On the right here, I have a part of a meeting transcript, and you can see what the big difference in readability it makes if we add speaker labels to this. Also, other applications, automatic subtitles or dubbing for movies, for example. It's important to keep track of speaker identity because you don't want the dubbed movie, you don't want an actor in a dubbed movie to sort of change their voice midway through the movie. In more general technology behind this is speech-to-speech translation, which is also used in meetings, conferences, etc. Then I've also listed voice anonymization and speech enhancement, both of which depend on keeping track of speaker identity, sort of extracting information about the speaker. Now, next I'll talk a little bit about the fundamental tasks that underlie this, these applications. So I've listed 3: speaker recognition, diarization, and speech separation. These all, they try to extract speaker-specific information, but at very different resolution. So you'll see what I mean by this in a second. Speaker recognition, in practice, it means either speaker verification, where you have a enrollment utterance, for example, Siri or Google Assistant. When you set it up, you give them a sample of your voice, and then anytime you use it, it's trying to verify if it is you speaking or not. If we move to identification, then we'll have a database of multiple enrollment utterances, and it becomes a little bit more complex. So instead of binary classification of signals, we have multi-class classification. So how is speaker recognition at rest usually? There's a lot of the speaker embedding models that are trained on huge data sets. So in practice, you tend to take a pre-trained model and sort of train a classification layer for your particular use case on top of it. On the right, I have a sort of a very high-level overview of these models. So you start with a signal, you go to some encoded latent space, and because you don't care about the time really, you just want to know across the whole signal what the embedding is, you do some pooling across the temporal dimension. But these pre-trained models, they're trained on single speaker utterances. So if you try to use them on a signal with multiple speakers, it's really, you run into a domain mismatch problem, which I'll return to later. But first I'll introduce the other tasks. So diarization is us moving now into higher resolution. So not only do we want to know who spoke, but also when did they speak. And also here, in general, we don't have enrollment utterances for this task. So it's sort of like labeling on the file level, where does speaker 0 speak, speaker 1 speak, like the blue line, where does speaker 2 speak, the red line, etc. And now the highest possible resolution is if we want to know exactly what each speaker said. So the clean speaker signals for each person, also known as the cocktail party problem, which the human ear is very good at. AI not so much yet, because it's really the highest possible resolution. We want to know for each sort of time frequency bin, we want to know what that speaker's activation is. A huge problem here is that we actually don't have any labeled data in real world. Because even if you had a headset on and you recorded a conversation, you would still have some audio from the other speakers picked up by the microphone. So for supervised training, we actually have to resort to synthetic data, where you take some clean speaker signals and you combine them to the best of your ability to get the training mixture. But this is very difficult because getting the dynamics right of a real conversation and the sort of acoustic environment is a tough task. And even people's voices change when they're speaking at the same time with another person, the Lombard effect. So it's really, really hard to synthesize this data. Yeah, I mentioned in the beginning that it's there's this common theme that we're looking to extract speaker-specific information. So a logical approach, common approach, if there's a similarity between tasks, is to do joint training. But so far, this hasn't been explored that much, and mostly it's been standalone systems trained separately for each task. And further motivation for this joint training is that often in deployment, we actually want multiple of these systems working together. So if we had a joint model doing all of this, it would be a lot easier. So why hasn't it been done this way? The main challenge is that the data sets that are available for these tasks. So as we increase resolution, annotation becomes harder. On one hand, we have speaker verification, where you just have to, for a signal, you have to say who spoke in the recording. So the data sets are massive and very high quality. And as I just said, on the other hand, we have speech separation, which there's actually no real world data. So it's quite hard to sort of combine these data sets. But I'll talk briefly about our attempts. We started small, so just focusing on 2 of these 3 tasks. Diarization and separation. It's a joint effort between our lab and labs from Toulouse and Toulon, where we wanted to sort of use this real-world data where we have diarization labels, but not separation labels, and sort of use that to train systems capable of doing both. So a very quick visual overview of how we tackled this. We take 2 mixtures from this diarization dataset. We have these diarization labels as well, because it's annotated with those. So now we combine those 2 mixtures to get what we call a mixture of mixtures. And again, the corresponding diarization labels. Then we feed it to the joint model, which we named after the cities Toulouse, Tallinn, and Toulon. It's a little tricky to say, but anyways, it outputs then this clean signals and, well, to the best of its ability, and also the diarization predictions. And I'll also show the loss functions briefly. So how we train the separation part is we try to sort of reconstruct those initial mixtures from this, in this case, 3 separate signals. The sort of this matrix A is like kind of dividing these 3 separate signals into 2 mixtures. And we have what we what's called a mixed loss. And for diarization, it's a very standard way that we took this pit loss for training, and here you can see why we actually call it Pixit. So it's just like combining the names of these 2 loss functions. Does that actually work? So we participated in 2 challenges last year with the system. The first one is Displace challenge, which focused on diarization, part of Interspeech last year. So it worked very well there. We got the first place in the diarization track. We also took part of the Not So Far challenge, which is more aimed at the separation part. So it's this meeting transcripts that I showed in the very beginning. There we got the 6th place, but we opted not to use any of the tailored synthetic data that they provided because the aim of our system is really to generalize to practical applications where you might not have, you won't have the resources to generate this tailored data. And it's all open source as well. And we've already seen quite a bit of interest on, suspiciously, a lot of downloads on Hugging Face. Okay, briefly about our current work that's under review. So I mentioned about the speaker embedding models that they're trained on single speaker speech. So if you actually have multiple speakers present, if you have overlap, they don't really do that well. So our current work is on sort of training a model that's takes as input, that's trained on multiple speaker recordings, and which is also able to output embeddings for all the speakers present. So not only are we tailoring it better for this multi-speaker domain, but we're also saving time in inference because we only have to encode once and we get all the embeddings. So benefits in both directions. And now briefly about where we see this work going. So this Pixit work was basically gave us a model that's able to do separation and diarization. And now the logical next step is also to add the third task. So this multi-speaker embeddings that I briefly mentioned, I can't give too much detail because this conference doesn't allow preprints for some reason. So you'll have to wait a few months to see details about this. But anyway, the plan is to combine all of these three, and hopefully by integrating them, we'll also get some nice sort of performance improvements in some of the tasks. But definitely it'll work better in deployment because, as I said, a lot of the times you do want multiple of these sort of outputs. Yeah, here I've I've shown two QR codes. First one is if you want to learn more about our work. And the second one is this the open source repo for the Pixit code. So training scripts, model checkpoint, and some like tutorial notebooks as well. And to conclude, we saw that the main mismatch is a big issue in a lot of these multi-talker tasks. And joint training shows potential in sort of better understanding multi-talker speech. But there is still a lot of work to be done to like integrate these tasks more deeply and really get to the point where we can say that AI can understand this multi-talker speech as well. So thank you, and happy to take any questions. I think I was a little quick.
We have plenty of time for questions. Let me start. How much in your work do you use pre-trained models and transfer learning from them? I mean, way before emergent abilities, there was the pre-trained models and transfer. And for speakers, I might be stealing a question from a colleague, but I mean, there are speaker models that you can tune to, you know, your own goals.
Sure, yeah, that's a good question. So we do use pre-trained self-supervised models, WaveLM in particular, which has been shown to perform well as a sort of a feature extractor for all of these tasks. But it's also been shown that it doesn't. You do want like pretty sort of. Sometimes you want like a probing head that's not non-trivial. So I think it's still important to work on models that work sort of on these tasks separately as well, in more detail. So yeah, we do use WaveLM.
Okay, nice. So, questions?
Thanks. I had a question about the speaker separation. Like as you said, this is something that you can actually have no real world data, right? Like authentic real world data.
Yes.
So what is it evaluated on this shared task?
So there's a couple of approaches to this. That's a good question. I didn't really cover the evaluation. One way is to just do evaluation on the synthetic data as well. You use some signal to noise ratio. But on the other hand, you could do this like basically meeting transcripts, which was this not so far challenge. It's sort of you use separation and then you do speech to text on those separated signals, and then you can sort of calculate the word error rate on that final transcript. So it's sort of, it gives you an idea of how well the separation is doing.
You're measuring it on like down the pipeline on a different task, basically.
Yes, the downstream task, yeah. So there is no like great way of doing it, unfortunately, on real data.
Cool. Thanks.
So I have a question about how well it performs and how big the models are, really. Because in separating different speakers, it really helps if you can also understand what they are saying. As opposed to if it's a foreign language that you don't understand at all, then it's also probably slightly harder to separate the signals. So if you build really big models, you can maybe get them also to understand. Small models are unlikely to be able to do that. What are your experiences with that?
Yes, great question. So the model size is roughly like 100 million parameters for this. And so far, it still takes quite a while to train. We don't have that much resources to allocate to it as well. So we've been focusing on quite specific sort of domains so far. If we want to sort of apply this separation to very general data, different domains, then I think it would definitely help to scale up the models further and the training data as well. So
practically, let's say subtitling a video, is that currently in Estonian doable with this or not? And marking the speakers separately.
Yeah, it depends a lot on sort of how much overlap there is between the speakers. In Estonian, people are quite polite, so there's not a lot of overlap. So I think in Estonian it works well. This not so far challenge was an American meeting data set, and there was like 40% of overlap. So I would say it sucks on that data set, honestly. But yeah, so the more you increase overlap, the harder it becomes.
Perfect. Hi. Yeah. I was wondering if you can use your model to clean audio. So if I have noisy audio, single speaker, would technically I get a clean audio with the output, or would your model technically separate the audio by just returning the same audio?
Yeah, so I guess if it can be used for speech enhancement out of the box, I think the way we currently train it, it would still like return a noise as well. I think you could use the same method, probably, if you, instead of sort of if you added some noise instead of a speech signal, for example. But I think this speech enhancement task is probably usually easier than separating sort of overlapped speech. So probably like you would use maybe a smaller model in practice.
Okay, thank you.
I'm not sure if in order to encourage the audience to ask questions, whether I should keep on asking while everybody's thinking, or I should just keep silent and take an uncomfortable minute and then somebody will ask. But I did have a question more on the practical side. So your lab has some applied projects, so transcribing radio and the Estonian parliament sitting. Do you see the work you presented today somehow contributing to the practical goals? So probably in the parliaments, are they also that polite? Or does it help the general transcription, or are there other tasks where this could be useful in practice?
Yeah, I think I haven't listened to the Parliament recordings myself. So if you don't have much overlap, then maybe you would focus on the sort of the true rightmost tasks instead, because then you can really like use a smaller model, which would be practical in that case. So far, we haven't. I don't think we've used it in any of our applied projects yet. It's more sort of experimental, I guess. But we do have this open source checkpoint, so you can try it out yourself if you're interested.
Okay, nice, thanks. I can go on until everybody's bored of it. I have more. Let me just ask one more. Let's see then. How language specific is the work here? And how, so can you just tell the signals apart by the voice without actually knowing the language? Because you go from audio to audio, right? So transcribing all three.
That's right. So I don't think we've tried it for the separation part, but for diarization, it's the case that it generalizes very well to like unseen languages as well. So it's mostly like English and Mandarin data sets that are used, but it seems to perform well across data sets. I think it's more about the acoustic environments maybe than the language.
Okay, nice. Nice. I wonder if it would perform nicely with cross-lingually zero-shotting you train on some languages and then apply to others.
Yeah, that's something to some future work.
Nice. So, last call for questions. Please.
Not so much a question, but I was just thinking about this separation and the noise thing. He was saying, like, would it be helpful to like try to separate it into like the speakers and the noise, or have you tried something like this? Because this maybe like clears the signal for the speakers, or I don't know.
Yeah, we thought about that one as well actually, and tried it quickly, adding sort of like a fourth and fifth output for noise as well. Our initial experiments didn't work, but to me it also makes sense to sort of not only separate speech, but also different types of noise and so on.
It might also be dangerous if you apply this in the parliament. Somebody's voice might be categorized as noise. So, if there's no more questions, then thank you once again. And we're moving ahead in our schedule to Joonas Puura, who is an alumnus of this building and is currently senior machine learning engineer at Bolt. And I hope he can keep up the pace with all the open source that has been presented, or not. I mean, the first two presentations really focused on open source. Let's see if Bolt can keep up.
So, hello everyone. Previous two presenters have really put me in a quite complicated situation. I'm not sure if I can keep up to their standards here, but I'll give my best here. So yeah, hello, I'm from Bolt. So I'm currently a senior machine learning engineer there, or a data scientist. We switch names daily. And I'm also a team lead for a small team there called Tools and Workflows, who's dealing with this problem. And what I'll be talking to you today about is about the use of recent technology and how we have been applying it to, more specifically, to customer support use case. So just to give a brief background why we care about this. So Bolt is running quite a large business at scale. So we are currently operating in over 50 plus countries. We have over 200 million customers globally. So we are working at quite high scale. And when we are working at quite large scale, this means that the complexity of the processes, the systems that we need to build internally within our company are also quite complex. And more specifically, when talking about customer support, first of all, at scale, if something can go wrong, it will go wrong. If you have 1% of chance of something going wrong, if you have 1 million things happening, you already have 10,000 problems that you need to solve. So stuff happens. And the point of having customer support in companies is to then help recover the users from this bad experience. And at Bolt, so probably all of you have used some of our services. So you may know that we are running actually quite a few businesses in one business. So we have ride hailing, we have Bolt Drive, we have scooters, we have food delivery. And that's what you see outside, but you then need to think that, okay, each of those businesses, they also have multiple participants. In ride hailing, you have drivers, you have riders, you also have businesses or the fleets. In food, you have even more participants, you have also restaurants and providers and all that. And as in the previous slide, we saw that we operated in quite a few markets. This also means that we need to take care of quite a few languages, as those markets, we are using different languages. So since especially we are in most of European countries, we are operating in Africa and also in the US now. And yep, so, and also what makes it quite difficult that we need to deal with quite like real world scenarios and just something happens in real life and then we need to recover from that. So just briefly to cover what is customer support. So if you haven't thought much about it, so I broke it down to a very, very simplified view. So everything starts from people using your service, and sometimes, sadly, problems occur. You order food, it's missing an item, or some drink were spilled, you were taking a cab, and then you saw that, okay, I was somehow taken a bit way too much money. So I have a problem. And what do you do in this case? You go into the app and you find support function and you create a case. So, and then this case ends up on the table for agents who then need to perform investigation. They want to get to understand what is the root cause of the issue, maybe ask some more additional questions from you, and then figure out, okay, what is the best solution that we can give the customer in this case. Ideally, the best solution for this problem is to not have any problems. So if you can fix your stuff, if you can fix your product and have less problems generated at all, then that's the best way to do it. And if you had no problems, you wouldn't need customer support at all. Sadly, not the case. So what we can then do is maybe we can improve somehow the parts of investigation. How does this work? Oh, wow. No, only there. Investigation and resolution. So can we speed up the process of understanding the issue and providing the best solution? Yep, so this is broken down again. So investigation, the end goal in the end is to match the support case or the case that was created to, okay, understand what issue is this customer really having. And the second part would tend to be to provide and figure out what is the best way to solve it. It can be refund in some cases. In other cases, we may just need to provide information about our policies to the customer. Yes, we are sorry about that it happened, but we can't do anything better in this case. Yes, the driver was late, we apologize, and that is where we finish it. And then the first step that a lot of companies have done, so since at scale, in order to solve those problems manually, it takes a lot of time, it takes a lot of training, especially if you want to consider that the rules of the business are also changing and you need to keep constantly retraining your agents all the time. So one way that businesses always try to find ways to optimize is to include some automations in their flow. So that's also what most of the companies are doing and also what we are doing. So for many years, we tried to solve it with something I call here conventional automations. And so both of those steps that were initially done by humans, we have some attempt to solve it automatically. And we take these two same steps. So investigation, we need to have some process to figure out some tooling. Okay, can we somehow automatically classify what is the customer's issue? So support case created, you have text, you have maybe order metadata, you may have like who is this user, and then you try to figure out, okay, what is this customer's issue? After you have figured it out, then what you usually did a lot was to run some rule-based automations. So if the issue is that, if the order was late, then you select this kind of solution for it, and then you apply what kind of actions they apply on top of it. So maybe give a refund, and also generate a reply, automatic reply based on some template. Yes, it works to some extent. The issue with this approach is that there are way too many different problems that you need to solve. You try to encode every single possible thing that goes wrong. It becomes way too many to handle, even writing all code. So what we also saw, we saw this in Bolt as well. So it became quite slow to scale. We are also quite a lean company, so we can't have hundreds of engineers writing in every possible rule that can go wrong. One thing you may also see that when you're plotting the curve of issues and how often do they happen is that it's a very, very, I would say, long-tail distribution. And one thing is, okay, let's just tackle the first ones, but it happens that the tail is also quite heavy. So a lot of the cases, they actually happen infrequently, but in total, in some, they happen a lot. And what we saw with this conventional automation, we also saw that people did and tried to figure out a lot of ways to abuse this system. So every time something goes wrong, they instantly go, oh yeah, I mean, or not go wrong. That's the worst part. But maybe I can get something back from the system. So yeah, we were in this state, and a few years ago, everybody knows something big happened, and now it's part of everyone's life in one or different way. So November 30, 2022, ChatGPT 3.5 was released. And I bet a lot of people also in this building got a lot of anxiety at some point. What is going to happen to my work? I need to start learning a lot of new stuff again. Is my work actually important anymore? And they really showed that it worked really well. And then we got another news a few months later, GPT 4.0, which, GPT 4.0 came even later, but 4 was, yep, it's really good. It's very human. It manages to reason quite well. Let's see what's up. Maybe we can also make use of this technology. So, as some people in this building may also know, that Bolt started something called the AI task force. So everybody was super hyped, from the engineers to the president to the CEO. Wow, this is such a great technology. How can we use it? How can we make our stuff better? So we created a lot of brainstorming. How can we apply this technology? There were crazy ideas. Make a personal chef, or make automatic trip planning, all this kind of stuff. I was talking with my product manager when I was in my previous team that they wanted to generate routing using LLMs, which totally makes actually not much sense, to be honest. So this is purely CS task. And what was found that the biggest potential for us was in customer support automation, just because how natural it felt. And then we had this tough question at hand. We have the system already working. We are automating a bunch of cases. How can we motivate this business case of pretty much starting from scratch and putting everything on top of LLMs? So what our product manager did, they took GPT itself, not that much programming experience on his own, and he created the demo to start and pitch this idea. So practically done in like 1-2 evenings. And they had already some working system in place. And this was quite a bit enough to already start, okay, yeah, this sounds cool. We get very natural responses from the bot. We don't need to generate templates anymore. all we probably need to do is just encode some policies and just ask, hey, this is the case, this is the metadata, this is the text, please do something, find the best action to do. And this is what happened. So we ended up with some parts still remain the same for practical purposes, and LLMs became the main drivers of intelligence, and the resolution, what LLMs also do, is purely a lot policy-based. Just to give a little bit intuition what is policy. So policies are practically rules that are written by domain experts. So how we want cases to be handled. So it can be like even natural language, which we are trying to move even more towards to. It's like, okay, this is the problem. This is the ways that we can handle those problems. Now figure out what is the correct solution to take. And those are also that we use then to do for data labeling and to evaluate the systems that we're building. Action space, so what treatments are available, what can actually the reasoning engine do. Some components in the system that we definitely wanted to have in place. So last year, the FOMO was definitely RAG. So how do we select information that is relevant to the case, and also using it to then generate the response. And other things that we want to do with the systems is also, okay, what does this customer actually want? Do they just want information? Do they just want to get a refund? Or what is the problem? One thing that we still have in place, we tried actually removing it. It's called solution prediction model. So we already drive when we get the case in, what is the output, what is the action that will be taken. Yep. So one interesting thing is that this actually helps to save quite a bit on costs as well. If you already know with high certainty that some actions are not taken, you can use way smaller prompts and just reason based on that, okay, which should be the good action to take. So this is pretty much what we have at the moment. So quite a bit of ML system design happening here. So I would say in real life, it's very similar. So what we start happening is, so some cases are created, then all this data flows together with order context, the metadata, all that. We classify what kind of, what is already the end results probably with different distribution. We have our RAG system in place. So find from knowledge base, so we have an internal knowledge base, public knowledge base, what are the relevant articles for it. We have the intent detection that I briefly mentioned. What is also quite important part of our systems is that we don't want it to go crazy. We don't want it to give like too much money and all that out. So we have a set of hard rules that is definitely says, okay, you cannot do this kind of action in this case. Please don't, please avoid it. And we take all this together. We select which actions are available with all the relevant prompts and rules. It gets composed into one part and then just goes through the reasoning engine. Some LLM guardrails. So if you were participating in this data science seminar a few times ago, Elena actually covered it quite a lot on what they are. So practically, we want to make sure that some kind of responses are avoided, that we are not promising what we should be promising, and all this kind of stuff. So yeah, this is what we have in place at the moment. So, and yep, it is something. So it is something, it works. And at some points it was quite a bit said, both internally, that it actually feels more human than sometimes agents themselves, because what agents often tend to do is that they want to save time as well. They create templates and then copy paste the templates, change one thing there, and then just respond with it. And LLMs, cool, they manage to generate way more human responses. So all solved. It happens that it's also always not perfect. So this was one of the things that I think happened last year. So customer opens up app, asks a question, hey, can I take scooters from Riga and then return them to Riga? And of course, yeah, take them to Croatia. Use them there. be happy, bring them back later. I'm not sure if they did it, but if they did, then I think it ended up as a quite unhappy place in the end. So this is actual human interaction we had. Yeah, there were multiple things that went wrong there. We weren't even supposed to automate this case, but it happens that we automated it somehow. So what do we do? So in this case, several options you do. First, you have guardrails that you don't make these kind of promises anymore. Definitely try to avoid it. But yeah, so 3 more minutes. So what I have here is some things that we as a team have learned quite a bit past years of working with text technology. As always with building actually any kind of ML system, the thing you definitely want to get right is how you are evaluating your models. If you do not understand properly how your stuff is working and how does it generalize to actually real population, you're blind. So you will do so many mistakes. If you have this evaluation cycle in place properly, you will be 10 steps ahead of everyone else. You're moving way faster. So the evaluations, if you know, then this is just like a representative sample of inputs and matching outputs, what you want to achieve. One thing definitely to pay attention to, that LLMs, they are still statistical machines. And first of all, they can have non-deterministic behaviors in some cases. So especially if you're using OpenAI, depending actually which servers you are hitting, you may get kind of different responses at time. One thing I didn't put there is that you definitely need to think also about this non-stable state, that really small changes in the prompts and stuff you're building can have a massive regression that can happen, so stuff getting worse. So this is also why you want to have elevations in place. Really good lesson always, don't use AI if you can avoid it. I always argue a lot with people is like, this shouldn't be solved with AI. You can just create a product where you click this button and that button and it's problem solved. You don't need AI here. Use less AI if you can. AI is definitely not all you need. So data, processes, having excellent process around it, tracking errors, makes everything way clearer. And yep, so also, you probably don't need a vector database at first. There you maybe have way easier solutions. So vector database is something that for us would find the relevant articles, knowledge-based articles and all that. And if I take one more important stuff out here is then build your systems in a way that you can really easily switch out the LLMs. Last year showed, this year shows even more. The competition is so big, the intelligence is getting better, the costs are getting lower. And so if you are like stuck to some certain providers, you will take a lot of time to do the switches. So design your stuff in a way that you can do easily the switches. But yep, that's all from me. So most important, focus on data from those and get your evals in place, properly measure your stuff. Yep, and thank you. We're hiring as well.
Thank you. So I'll shoot a first question. Do you still use GPT-4 OpenAI models for it, or did you do what you preach and start switching and choosing?
So we have multiple providers and contracts with different providers. In some cases, we do use GPT-4o. This current state is still on 4o that we have. Some parts of the systems, they have higher requirements on latency, and they maybe don't need to be that accurate. So we can switch out to some mini versions and all this kind of stuff. But we are considering many different. We have AWS, they have a plurality of models that they give access to, DeepSeek probably as well and all that. And yep, or Gemini, even Google. So.
Okay, and did you consider tuning a model of your own? I mean, you have customer support data from way before. Do you trust your customer, like before you fired them, or I don't know what you do with them once you automated customer support, they probably generated a lot of data?
So we have definitely considered doing fine tuning and all that. What we reasoned, it's most likely not worth it, and we saw way more value of getting our inputs and data and prompts correct. I say that fine tuning, it comes later in this process. So we actually one thing to consider is like, I would say that reasoning for our use case is pretty much solved. So if you have your input in place, if you have your policies in place, reasoning is working really, very well. Like we tried switching out to the 4.5 and stuff. Very expensive experiments, but it was, but didn't give us much gains anymore.
Okay, interesting.
I think thank you for the presentation. I think I partly got the answer, but it was AWS. So my question is, how much are you considering self-hosting, on-premises hosting versus somebody else providing ready-made models?
Mm-hmm.
For RAG, you need to host something, I guess. Well, anyway, yep. Comment on that.
Yeah, so this is, I would say, a big business decision to make. We initially actually had the discussions to, hey, we should train our own LLM. We have a lot of data. But when you start to consider all the technical costs of both hosting your own LLMs and also having the qualified engineers to actually take care of all of this infrastructure, this cost is actually for us is at the moment way higher than buying it as a service from outside. So either like some direct access from AWS or OpenAI or Gemini, this is way cheaper for us. Of course, it has some bad sides. So if the services go down, then it's trouble.
Thank you for your presentation. By the way, I arrived here by Bolt Drive also. And of course, I had a almost flat front tire. But my question is, which of Bolt's products, I mean, food delivery, taxi, or which one is the most problematic? I mean, which one generates the most customer support? And another question would be, do you try to solve only the simplest customer problems, meaning that the complex problems would go automatically, or at some point when the bot decides that it's problematic and complex and assigns it to a human?
So yeah, two great questions. So first is what areas are the most problematic, either to automate or to actually for business itself? Which one did you think? Which is more problematic to automate, or which is actually like generating a lot of cases? Which one were you more interested in?
To automate.
To automate. I would say that all the cases where it's like you don't have clear solution maybe at hand, those are problematic. But like when it comes to the he says, she says kind of issues, is that where you don't have like specific data point available to make a decision, how can you solve this? So you need to do some decisions there and there. So if you can't do just if else, then it becomes hard. Market-wise, I would say that the food is, since it has just more participants, it makes it hard to understand the problems. So this is, since you have 3 partners already on the marketplace. And the second question was that, so yeah, purely business. So what we choose to automate, we optimize for impact quite a bit in all of our plannings and stuff we do. We also now, sorry, not now, but we always have trade-offs, okay, quality, we have impact. So we definitely we understand what issues are the most important. So if we want to get business impact, yes, we want to focus on the ones that are happening more frequently. So this is the place we can save the most of the time. So yes, we are optimizing pretty much, okay, this is the cases that we haven't solved automatically. This is where we want to put our energy to. And all the cases that we see, okay, these kind of issue types, this is so infrequent, just let agents handle them. So that's the business answer here. Yeah, Navin?
Hi, thanks for the presentation. You had an example of the scooter incident. I'm wondering, how do you detect these edge cases? Because you mentioned the volume about 1 million. I don't know if that's actually based on some real statistic of your business or not, but I assume the volume of customer support issues are really large. So how do you actually detect these edge cases?
Yeah, so while I can't give specific numbers, this was more of an example. So just if you have million orders, you get, if it's 1% of possibility, then you get how many tickets. So, but edge cases, usually how they happen is that this happen and then customers contact you again. Like, hey, I got this response before, I tried to do something, and now I ended up with another problem. And at some point they get to real humans, or they get escalated in some way, maybe through media or some other, then or directly to CEO at sometimes. And then we realize, okay, there is potentially some issues. And of course, we run our own AI quality programs to like specifically, hey, please go through those cases, check where the common issues are, please map them down, so we can start to understand, okay, what's going wrong. And nowadays, what we are looking more into is this LLM judges, which specifically start to figure out and find those common issues that you may have. So you can just say, this is my prompt, can I find cases that are similar, that are matching with this prompt? So you can use LLMs itself to actually do quality controls.
Mm-hmm. Thanks.
We have time for maybe one more question, and then we have a coffee.
Yeah.
Chatbots so human-like? Do you even tell the customer that they're chatting?
Sorry, I can't hear you.
With chatbots so human-like, do you even tell the customers that they are speaking to a bot?
Yes, we have like indicators in the chat interface that they are speaking to a bot, yes.
Have you compared, actually, I mean, everybody knows LLMs hallucinate, but probably the customer support agents hallucinate as well in their own way. So did you compare the rate of hallucination of both humans and LLMs?
First of all, measuring number of hallucinations is really hard. If you knew that it's hallucination, you already can avoid it. Secondly, yes, we have seen, but mostly anecdotal cases. That the customer asks one thing and what the agents can end up doing is deleting their account. So this has happened in real life, so yes.
Yep. But have you gathered feedback from customers themselves? As in, do they prefer the LLMs or the actual humans dealing with their support tickets?
So yeah, so do humans prefer chatbots or they prefer humans? So one of the sad things here is that the humans, they have had this bad experience of chatbots for many, many years. And they have become quite allergic to even the word of having a chatbot, so they try to avoid it in every possible way. But we also measure the classical all customer support metrics in a way. Like I would say that if customers are getting their problem solved in the end, they don't care, to be honest. So if they are getting their money back, if they should be getting their money back, then there is not really much difference.
Okay, I see there are more questions, but let's maybe take them for offline. It is time to take some coffee and some snacks. So first of all, thank you, Joonas, once again. Thank you very much. And we should be back at 6 sharp. So while everybody is settling down, I think we can just start already. Welcome back to the second session. To follow up my question to Joonas Puura about not just LLMs, but humans hallucinating, I was reminded over the break that the data science seminar is actually 8.5 years old, not 2. Not only that, but this is the 40th seminar that the Institute is holding. So sort of like an anniversary. So big kudos to everybody who actually started this and keeps it going. But now I'm handing this over to Risto, who is a data analyst and a developer in Feelingstream and has probably been there longer than we've been organizing the data science seminars. So the floor is all yours.
Hello. As Mark already mentioned, I am Risto from Feelingstream. I will be talking about challenges of automatic speech recognition in mostly Nordic Baltic languages. But before I'm going to talk about the challenges, I'm briefly talking about why is it important for our company and why am I here. Feelingstream is a small Estonian startup which basically provides a platform for contact centers to transcribe and analyze different kinds of customer conversations. Mostly it's about phone calls because this is very interesting. You have emails, you can read emails, but if you have like a bunch of phone calls, you probably have to listen them to gain some understanding. And a big part of our job is to work with automatic speech recognition. And once we have transcribed the phone calls, we can analyze them in every different ways. What is the quality of agents? What are the topics? Which of the calls are unwanted, which we want to reduce? Which of the calls are something that we need? We want to how to do more sales and stuff like that. But everything starts with the data, which is probably all of you already know. And the data goes through some pipelines, and from pipelines we have different problems. ASR process on a very high level is in the following slide. There's somebody speaking something. There is a system that stores, transmits the signal, do something with that, maybe processing in some way. Then there is some model that is processing the data that is stored, doing the ASR part there. And finally, there is some end user who is going to read or use this transcript somehow. I'm going to briefly give an idea what are the challenges we face every day in each of those steps. And the fun part is that problems start even before anybody starts speaking. The problems come from the languages, for example. If you go to Norway, then there is multiple of issues. First of all, there are 2 official written languages, which makes a decision like which way to write this transcript. Okay, this is one problem. There's Nynorsk and Bokmål. Nynorsk is not so popular as Bokmål. Let's say we take the most popular language, the written language, but there's a huge amount of dialects. And not just huge amount of them, but you could say that almost every valley has their own dialect, because physically are separated. Most part of the years when you have a lot of snow, you don't want to go too far there, it's dangerous. And so different dialects have been formed, and people speaking those dialects sometimes don't understand each other. Some of the dialects are really, really different. And the fun part is, of course, that if Norwegians are calling to Swedes or Swedes calling to Norwegians, then they kind of understand what they're saying, so everybody can speak their own language. So one part is in Norwegian, one part is Sweden. Also in Estonian, I have heard phone calls where one participant is speaking in Estonian, the other one in Russian, and they understand each other close enough so that you don't need to switch to common language, but you are feeling more comfortable using your mother tongue. And the Norwegian sample provides a lot of funny examples. This is just one sentence. I asked from my one colleague that, can you provide me more samples? And she told me that, yeah, I can, but they're like pretty dirty and sexual. I said, I don't want my presentation to be edited out from this seminar. So this is one way, one word, or one sentence, which in most of the Norway understand that you have to call to the cow. Well, yeah, I don't know why you have to call to the cow, but some dialects understand that you have to throw up on the cow. And there are samples where basically one sentence means positive thing in one dialect and totally opposite in another dialect. So if you say that you understand Norwegian, then it's a very tricky, which part of the Norwegian do you understand? Now, okay, let's say that we are not working in Norwegian. And we have some, like Estonian, we have like some dialects, but you have like very common form of what the language should be written and how pronunciated. Now, if somebody starts speaking, there is still some challenges. We are working with phone call data. We can't control who is calling to contact centers. They can be whoever they are. We have been at cooperation with Estonian, like equivalent of 911, 112. And people calling there usually are not in a happy situation. You have a problem. You're in a car crash, somebody having a heart attack. They don't pronunciate words very well. They are in a hurry, they're nervous. There's a lot of background noises. They are in high speed. And of course, in some of the cases, what we are seeing is also that the younger generation might use a lot of slang. If they call, they prefer not to call anymore. And this is an issue because a lot of training data that is publicly available is too good audio, because it usually has something that is audiobooks or even some, I don't know, radio shows where people speak in normal volumes usually, and they aren't too nervous there. And we are working with spontaneous speech, which means that you don't kind of edit the text. You don't even have a plan what you're saying. You remember 3-4 words which you said, and you plan like next 2, 3, 4 words ahead. And it's the stream of tokens coming from your head, which means that it's pretty impossible to put punctuation there so that it would be grammatically correct, because there isn't much of a grammar there. And it's full of self-repetitions, filler words, stuff. For example, if I don't know what I'm going to say in next words, then I'll fill up the blank here something, I'll make some noises. And also coming from the speaker side is, getting more technical, is like what kind of devices are they using? This is something, again, we cannot control. If you have a podcast, if you are in a radio, you're in a TV, you have like a control what kind of device somebody's using. And quite a few examples from reality. In Corona time, one of the contact center allowed people to work at home. The agents were working at home, but some of the agents had problems with internet connectivity, and the signal was poor. The customers didn't understand what the agents were saying because of the bad internet. If the internet is bad and if the signal is bad, then it's very difficult to even understand what he's saying. You can have a great ASR model, but if you have a signal that is missing most of the information, then its output is not going to be great. This is not too common, but customers also can use whatever devices they have. So maybe your grandfather using second verbal telephone can call a contact center, then we have to serve them. The service providers have to serve them. They have to answer something there. And there is like a huge difference, because I've made tests, like iPhone microphones are really good, but if you have cheaper phones, then it might have some issues that the quality of the signal is not so good. And then it depends on like how far are you from the microphone, in what room are you, how much background noises there are, and this is going to distort the output. Now, on a getting more technical level, if you have, let's say, good language, speaking in a normal way, not rushing, you don't have a lot of background noises, you don't use second verbal mobile phone or phone. Now the audio is stored somewhere, or it's like processed. Now it's getting the issue, like what is the technical quality of the audio stream or the audio file, which usually the contact center platforms are themselves stealing. So I would say like 2 main characters which are most important is sample rate, how many samples per second for audio signal it's storing. The minimum quality we would like to have is 8,000 hertzes. Better would be 16,000 samples per second. Most of the training data publicly available is around 16,000 hertz is what I've seen. There are some samples that are in lower quality, but 8,000 is something that we are working with contact centers in most of the time. And the other thing is, so the sample rate is here like vertical lines, how thick they are. How many samples per second do we have for audio signal? And the second thing is bit depth. It's like the horizontal lines, like how many unique values can we take in this range of values that is allowed to have this signal. So for example, from 1 to -1 or 1 to 0. And the more values we allow, the better the quality will be because the construction loss for the signal will be small. But contact center platforms are again optimized for storing the audio as small as possible. So they try to chunk it down so much as possible, do a lot of filtering, do compression, so that a human ear can understand what is said, but the audio itself is not very high quality. It's not something that you would even see some YouTuber doing in YouTube. So we usually ask the providers that can you give us the better quality files for the transcription time? You can later store it in your systems as in a quality you want to have, but you don't have to, but you can't give us very poor quality. And the problem is that once they give us the file, the systems that are processing the data are complex, and there isn't probably one person in a company or somewhere who is going to say that we have this configuration and we are doing this filtering, we are doing this compression, we are doing this whatever signal enhancement. And you get just audio file. You will see what is a transcript out of that, and if the transcript is not on a satisfactory level, you will have to be Sherlock Holmes and see what might have been done there and give hints to the people there. So this is very stupid and simple sample of audio's kind of spectral analysis, where you can see on a horizontal scale different kinds of frequencies. So this has frequencies up to 8,000 hertz, which means it is 16,000 hertz sample rate. 16,000 hertz sample rate means that you can store information up to 8,000 hertz in a frequency level, which is, I would say, more than enough to have a capture human speech. The tricky part is you don't know what has been done to the audio. You will get this one, what is on the lower part. That is filtered already. You can see that some of the frequencies in around 4,000 hertz are missing. It's good that I can see that there's something obviously missing, but sometimes it might not be the case that something is really missing. Maybe something is just a bit of downgraded, maybe something is a bit of shifted. And now it's your task to like kind of understand what has been done there. Usually it's the case that the higher frequencies have been just filtered out or cut out basically. So that you have audio file that could have information up to 8,000 hertz, but you see that everything after above 6,000 hertz is gone. So you can already detect that something is missing. Now, once we have audio, we have like processed that and stored as a file. Now we have to do this automatic speech recognition, which is a crucial step to get the output, but it's also challenging because customers that we are facing, they don't care about how cool ASR models do we have, because they want to see the output. They want to have it as cheap as possible. They don't want to pay for that too much, especially when you have like a free market of Whisper, whatever outsourced models that you can use. So what the customers expect it to be fast. We provide also service so that you can install it in-house. So that means that customers are not going to have GPU clusters. Everything must be running on CPU, which is a bit of challenge if you want to do it fast so that it won't contain consume a lot of resources. You want to have a model, or we want to have a model that transcribes 1 minute of audio faster than 1 minute, which is not using GPU, and being accurate enough. And also the output, in our case, has to be, definitely words or the tokens with timestamps. The timestamps have to be accurate because we later also anonymize the audio. We detect where are the names, numbers, stuff that is giving away personal information. Some capitalization punctuation that can be separate model or be part of the ASR model, depends on architecture and on the solution. And also some confidence and probability. How probable the model was that this token is correct in this timestamp. Because this also gives information that, for example, if somebody is saying some words and the overall probability of this transcript is low, that we can say that maybe it's a funny dialect, maybe it's in a funny pronunciation, the quality might be poor, and we can detect where the quality is poor. And that also means that we can't use only the one that is state-of-the-art, because state-of-the-art models like maybe Whisper, they have a lot of training data inside there, but they doesn't give natively very good timestamps. Yeah, I can have a separate model to add timestamps, but this is now more processing, this is more resources. And again, customer doesn't care about that. They don't want to pay for that. They want to have a cheapest transcript, possibly the best one, but the cheapest one. Which basically means that all of the work we are doing is a kind of a trade-off between accuracy and resources. The transcript has to be so good that we can do the analysis so that you can read the transcript, you can understand that, your eyes wouldn't be bleeding that, oh, those words don't make any sense, I can't understand this thing. But it doesn't have to be like 99.9% of accuracy. If it's already like 95 and nobody complains that, oh, transcript is so bad, then we don't use resources to go up above that, because we need a lot more training data, a lot more resources to get higher accuracy, which is really kind of a Pareto efficiency or effectiveness for us. There's a trade-off. Above one point, you don't need more resources because everybody is kind of happy and nobody complains that, oh, your transcript is very poor. But let's say we are not in Norwegian, we have good pronunciations, we don't have Second World War phones, we have good models that are fast, they're transcribing very well, nobody complains. But we have end users, which is also a funny thing that end users are not used to reading spontaneous speech. You don't read spontaneous speech, you read something that is written, that is somewhat edited already, even if it's a chat or Facebook comment or something like that, that has been edited. Somebody has usually thought through what is he or she is writing. Spontaneous speech, it's just stream of tokens. This is just one example from the internet, which you can see is already a bit of challenging because you have some filler words, some repetitions, self-correction. So I didn't mean that. I wanted to say something else, which basically cancels some part of that text before you said, some restarts, and funny pronunciations. If you don't know, then you just make this vocal very long. Oh, okay, what I'm going to say now, and fill in the blank here, which really doesn't have much of a meaning. Besides that, I didn't know what I was going to say now. I'm trying to think out what is going to be the next word, which makes it difficult to punctuate. So to add any punctuation, there is like, you can use some grammar rules, but mostly not. And I say that you can add few dots here and there, few commas here and there, and it doesn't matter where you add them, because the main point of that is to make this text more readable for the end user. If this text wouldn't have any punctuation, it would be very difficult to read. But if it has some punctuation, even if it's almost random places, it still makes it better. But the end users, I have had many cases where end user is reading the transcript before listening to the phone call and saying that, oh, your ASR model is very bad. I can see that it's total gibberish here. we put the audio playing and they say, oh, okay, this is the way we are speaking. Your ASR is pretty good, but I didn't know that we're speaking in that way. And we don't edit the text anyway, because we want to capture what is really said in correct or in mistaken form in any way that is there, because this might be valuable information. For example, are there any parasitic words in some agents that we could like help them to train out? Say that, hey, you are using this word and it really is not necessary for you to use anywhere. But most of the time, people who are dealing with the transcripts, we have to like give them time to get used to that you can like skim through the text and see that, okay, those, yeah, they're funny parts, but you don't have to focus on that. Which also makes sometimes difficult to evaluate what is the real accuracy of the ASR, because on a typical level, you measure word error rate, which is basically all the words that are missing or wrong in a transcript divided by all the total words in what are correct in should be in the transcript. But this is, I would say, like statistical word error rate, and most typical words where mistakes happen are here, is, that, and, or, no, yes, which are not so important. They don't contain so much information, and we try to focus on business critical words, because if you miss product names, you miss verbs that are important, like filing a complaint, unhappy, geographical locations, some whatever names. This is important stuff that we cannot miss. If you miss some filler words that even the speaker themselves don't understand or don't remember what they said, this is not going to be a very big mistake. And above all, later analysis, we focus on business critical words. So in conclusion, I laid out a bunch of challenges or problems, whatever you want to frame them, that we're dealing with. The solutions we are having is that you have to have, first of all, knowledge in what language are you working with. Is this language already complex? Is it like Norwegian? You have like hundreds of values there, and you know that you're going to miss some of them. But is it important? Maybe there's like most of the people are near Oslo and they speak those 4 dialects, which we have to be very good at. And also like what the training data is. Because if you have like a bunch of training data that is audiobooks, that is very well pronunciated, very well stored, that is with high quality, but we are working with phone calls where the people themselves might even not know what they're going to say in the next 3 words. This is totally different structure of the data. So that we are focusing on more on getting smaller data sets, but more like aimed at the production level accuracy that we want to have. Phone calls with poor quality, poor pronunciation, with some of the quality aspects that we need are missing. And this gives a huge boost compared to the models that have hundreds of thousands of training data, but still cannot perform on this exact level. And of course, finally, it's about trade-off, because we want to earn some profit. What is the cost of the solution versus what is accuracy? The accuracy should be so that it's on a tolerable level, on a good level, but if adding more accuracy doesn't like really give you anything or to the customer anything, then it's not worth it. So in the end, I would say like, yeah, data quality is a big issue, and it's a thing that helps us quite a lot. So thank you.
Thank you very much. We definitely have time for a couple of questions. This even works. Do we have questions? Please.
Thank you for your presentation. I just have one question. You must do some kind of corrections. The end users don't want to see if you extend some words, like you had the sure in a long way, or maybe the end user can click on and off that feature or somehow.
We basically, one of the corrections we do, or which is already in a training data, is that we usually say or try to store the data in a correct written form if this word has some written form. So if you like pronounce it some word as a very long, or some characters there as a very long form, then we say that you have to write it still as in a correct written form. So just variation of pronunciations, because otherwise it would be a lot of ways to write one word.
And can the end user choose some filters or something? Like I said, if does the end user have some filters that he can click on to get the different results? For example, those words.
Basically, no, because the end user has only choices to see our transcript or see our transcript in an anonymized way. Because some of the people inside the companies are not allowed to see the full names, for example. But I would say that the transcript for us is kind of a hygiene factor. It's like the tires of a car. You won't buy a car because you have like nice tires, but you have to have good enough tires that you can drive a car. For us, we use the transcript to provide like a kind of a real value. If you have thousands of transcript and find patterns there, then it's not so important like one word here or there.
Okay, thank you. I think let's thank Risto again, and we have to go on with the program, and so all other questions can remain for the discussion afterwards. And let me introduce our final speaker, who is Agnes Luhtaru, and she's a visiting researcher at the University of Texas, Austin, and a PhD student here at the University of Tartu. Agnes, do we have you?
Can you hear me?
We can hear you.
Can you see me?
Floor is yours.
And can you see my slides?
Yes, we can.
Awesome. So yes, I'm joining you from Austin, Texas. I hope you are having a lovely evening. And yes, I am talking about robotics. So, but a bit about my background. Mark mentioned that I'm a PhD student in the University of Tartu. And my background is mostly in natural language processing. I have been working with different applications, training models with text and speech, and played around a little bit with multimodal models as well. But yeah, but currently I am in a research group in University of Texas that's called Nuclear and Applied Robotics Lab, and focuses on really putting robots in real life situations to make people's lives better by taking people out of hazardous environments, or in other ways making the life easier. So yeah, I'm going from a really language background to a group that does a really little machine learning or NLP, and that's a pretty unique gives me a pretty unique perspective, I think. But robotics and AI, we see a lot of new demos, like in every few months, something new seems to be happening, and powerful companies release new demos showing that progress is being made, and how we are moving closer to embodied AI and intelligence. And when we look at the research around robotics and AI, we see mostly two different directions. We see different models like ChatGPT or different vision models used for robotics applications, usually for like planning what sequence of actions to take from more general language commands, and then using some kind of pre-planned actions to then actually execute those. And also we see a lot of models used in perception, understanding the visual input, and interpreting human commands. And then there is another area which focuses on end-to-end training, that we take our experiences, camera data, language command, and everything, and put it into a model and get trajectories for executing the task. And I'll first talk about a little bit about what are our findings about the second one, where we focus on seeing how feasible would using that kind of models be for practical applications. And this is just started with a collaboration with my colleague from UT Austin, who also works in Los Alamos National Lab. She came to me saying, like, I see so many claims about embodied AI, that we have language understanding and generalization and all those few things that we would like to have to put robots in unstructured environments. And but she was also saying that when we look at what we can do right now, it's not matching the claims. And when I look at the data I have used, or I see them using, then it's not matching. Something is wrong. And we really started looking into some of those data sets that are used for those models. And we looked into more, but here put the two examples, namely OpenX Embodiment, a huge collective of bringing data from different universities and labs together into one unified format and then training models on it. And we found that in terms of language, these datasets are extremely extreme lack diversity, that the language commands that are together with these trajectories for doing different tasks are very simplistic and repetitive, and lack what we would test in language understanding, like reasoning and understanding states or negation or stuff like that. And may also lack from visual and language grounding perspective diversity in terms of one object used for one task, meaning that model can learn those biases that, okay, I see an apple, I will do what I've learned to do with an apple. So yeah, and also when we look at some of the data sets, there are also like just common sense reasoning or safety problems, like since the data sets are crowdsourced, that like stab the knife into a table or put the knife in a microwave, which is not the behavior we would like to learn. So the conclusion we have reached, like the data we have currently, we do not see like very practically useful. It's good for developing algorithm and methods, but evaluating the systems for real world use, we are just not there yet. So maybe if we have a lot of data for specialized tasks like folding and manipulating different color blocks, then we can do those tasks, but it's really not very generalizable, and there are a lot of papers about adversarial attacks in these models. That is just a lot of research needed for using vision language action models or multimodal models going to action in practice still, at least in very unstructured environments with people. And yeah, so when we are talking about real world applications, then as I mentioned, we have to consider that the real world is messy. Humans behave in ways that we cannot really easily predict, and we really have to know how the models will behave and what will they do if they see an object that they cannot make a decision for, etc. So coming back to the more like using different trained LLMs or VLMs or multimodal models for robotic applications via pre-planned actions. We started focusing with two other colleagues of mine on a really practical application that would be very useful to have in the real world, which is using robots for picking up trash in social or environments where it's not really clear what can be trash. And yes, we can build an application with the current tools. Like I think there are various ways how we could do something like that, but something we came up with or currently stuck with was using GPT-4 API for asking an LLM, okay, I want you to name what trash items there are in the environment or the image that you're seeing. And then we were using open vocabulary object detection model for getting the bounding boxes. So we would get descriptions like crushed soda can and put them into open vocabulary object detection, get bounding boxes, get the center coordinate, and then send it to Boston Dynamics API, since we were using the lovely Spot robot. And yeah, here you can see the application working. My colleagues also built the trash disposal logic for putting the picked up trash to the bin that was mounted on the robot. And yeah, with that kind of logic, we could easily pick up trash. But then there is a question like trash, but what exactly is trash, or what should we collect as trash? So how do we make sure that the robot is not picking up something that's actually valuable? Does it know what we would like to consider as trash or for who it's trash. Examples like we can see the object of like Corona bottle looks basically the same. It can be filled with beer, it can be in different environments, but like it has really similar, like the object looks very similar, and based on the environment it's in or a state of whether it has beer in it or not, we should decide whether we throw it away or not. And yeah, in some cases, it's even not completely obvious for humans that. And yeah, other example of like, if I have information about how long some kind of object has been in the scene that we could get when robot stays in an environment long enough, can the model use that information and make a better informed decision based on that. For example, if a coffee cup has been only on the table for 30 seconds, it might not be trash, but if it has been there for 4 days, then it might be trash. And maybe it's my special coffee cup and I don't want to throw it away, then it's not trash. So it's really ambiguous in that sense, like whether something has the property of trash or not. And yeah, in some cases, the change is also gradual, like the flowers when we buy them are definitely not trash, and when they start gradually getting older, then at some point they will become trash, but like it's not clearly defined when does that change happen always. So yeah, we were focusing on cases like that and wanted to test how similarly would people and LLM see trash, and constructed different data sets of similar objects in similar or in different contexts, and then asked 5 people, do you think this is trash? Or like name the objects that are trash, and then divided the objects into ambiguous or clear trash or clear non-trash cases. And then asked GPT-4 the same thing. Here with the prompt, with examples, we give some kind of indication what do we consider trash. So that definitely has an effect, but we see that with clear object where all the participants that we asked if something is trash said that yes, this object is trash. We see that LLMs name a lot of those objects, but in cases where like either 3 or 4 out of 5 or 1 or 2 out of 5 say that something is trash, it's more unpredictable or ambiguous what kind of answers we would get, indicating that in some sense LLMs might also not be fully sure about those objects. And yeah, so when we have the information like whether we could classify it as something as trash, we can either pick it up or try to acquire more information and add that to an LLM, like the time information, or if there is a human present, then we could ask the human if they think it should be thrown away, or maybe we just need another viewpoint of the object to make a decision, etc. So if we can qualify or quantify which objects we are not sure of, we can start building the logic of what should we do then. So yeah, the simple case of just picking up trash in a context of real world becomes really difficult, because in the real world things are not clear, and the information necessary, or like we know as humans for making those kinds of decisions plays an important role. Like we know about social dynamics, like when people live something, and yeah. So so in conclusion, the real world is difficult and messy and complex, and we need to know what the models are doing and what's in our data. And yeah, we have really interesting problems to solve. So yeah, that's all from me.
Thank you. I like that the conclusion is there's no such thing as a free lunch, basically, and that you have to know your data and domain and so on. Do we have any questions? While the audience is warming up, maybe I'll start. You showed examples of a previous data set with a synthetic visual world, basically. Could visual models be pre-trained on that and then transferred to actually real world?
Yes,
successfully?
people do that, but I'm not fully sure how well it works. I think as a pre-training, it's definitely a good option, but there is a huge area of research focusing on sim to real, and I'm not sure how well it currently works, because the simulation data is definitely useful if we also have real data, but to get from simulation to real, we need to have still good quality real data as well, I think.
Okay, that makes sense, because if you try to train a multimodal model with the text and the descriptions and the actions, I mean, then I wonder if it works at all, but I think you are very right that if you mix it with the real data, then it can probably learn some. Do we have any audience questions? Does anybody like trash? Edward.
So I was wondering how these robots are working, because as little as I know about robotics, the problem is to embed, to put physical theories inside the robots. So they don't understand common sense physics. And I saw that you have a robot there that picks up trash quite well. So I was wondering how it works, because at the beginning of your talk, you said that in the new domain, you don't use NLP, but at least you use GPT-4. So this is some NLP, and these machines do not use machine learning. So I was wondering how they really work.
In this case, we use the Boston Dynamics API in some sense, where like the API just as ChatGPT can do stuff that we don't know exactly what they're doing. Has a functionality of like, there's a coordinate, pick it up, and we don't know exactly how that works. It uses the depth camera to estimate the object in some sense. We found that it doesn't work well with like dark objects or very close objects, etc. But we don't actually know. And yeah, we combined it with just pre-planned pick and place algorithm of like, we want to go from this coordinate to this coordinate to actually put it in the bin. So I don't know if that answers the question.
Yeah, because I mean, years ago I've seen a talk that these are trained with genetic algorithms, these robots, and so therefore there is some machine learning there.
Yeah.
It's not that they have some theories inside about the physics and then they pick up the objects. They have to recognize them. There is machine, there is vision there. There are many things, I think.
Yeah. Yeah, there is definitely some kind of machine learning in play in everything that Boston Dynamics has built. Yeah.
Okay, thank you.
Do you have any other questions, audience? Please. I cannot share my mic this time. Oh, thanks, Emil.
What's your personal opinion? How far are we from the I, Robot movie, where is the Will Smith, where a robot helps with all the works, all your household jobs? How many years would you think?
I'm always very pessimistic about that, and I think that robots, like things that are easy for humans, are still really hard for robots, and I think it will take a long time to actually get to a point where we can reliably have robots in environments that they can face with unexpected things and can actually reason about what's going on. So I'm really pessimistic about that happening like next year or in a couple of years. We have robots everywhere, but maybe I'm proven wrong.
Currently, we have text robots everywhere, so maybe we'll get to physical ones.
Yeah.
But if I may, a follow-up to that. Okay, so if we don't ask in how many years do we have the solved robots, but at the moment, would you say prompting delivers state-of-the-art performance? If we have a ready API of the physical bot moving, and we have to interface between the visuals and the robot behavior, which has some kind of a behavior protocol or control through API, would you say prompting is the state of the art, or is there something that's more reliable for the general case?
What do you mean by prompting?
So, I mean, what you described here is basically the GPT-4o model gets an image and a prompt, and then it can decide if it's trash or not, but you can also probably prompt it to generate commands to the robot where to move, how to go, and so on. So is that the state-of-the-art approach currently, or at the level of the state-of-the-art, or is there a more dominating or more like better performing approach to guiding the robots, from visuals to their actions?
I think it really depends on the use case. I think when it's needed that robots behave in a very controlled manner, like in very dangerous applications, you just cannot do that. And people are using more traditional methods for that. And in cases where we do not we need some kind of more reasoning ability, I would say yes. Prompting combined with other tools is like to actually doing something with robots in the real world as the state of the art.
Okay, thanks. I realized I wasn't looking at the clock. First of all, let's thank Agnes again. And it's time for the final part of the event where let's please invite all the speakers from today to come into the front and join the panel. So Risto, Joonas, Amit. Now it's, I think, live. I don't know, I can just give the mic and then you can pass it on. So this is the part which I promised to everybody, where you get to ask beyond today's presentations and actually about the modalities. I'll probably do a warm-up question, and all of you today described different applications of different AIs. I don't know if you put it in plural that way, but and I think most of you mentioned that data is a problem. I think the other problem for developers of AI are users. Not really the problem, but educating the users about using the solutions and what they do or do not do. Can you briefly talk about the experience? How do you actually educate the users or prepare them for your AI solutions?
I guess I'll start. I think at Sign we have two types of users. We have deaf users and we have businesses. Deaf users require from us zero education. We want to adapt to them. Whatever they do with our system, we would like kind of to support it. However, businesses don't understand how to be accessible, and they don't understand what the needs are of the deaf. And so we seem to be doing a lot of education work with businesses to explain how they can become accessible, not just through text.
Okay, thanks.
From our perspective, our customers are big companies. Somebody who already has a lot of data, they want to analyze that. And we have like kind of official program to onboard them so that they would be able to even ask the right questions if they want to get some answers from the data, read the transcripts, and not to pay attention if people are not talking the way we are used to writing. But on the other hand, it's also like customer expectations are getting higher because now everybody's talking about generative AI and it's a very cool word, which also means that on the other hand, we have to work with product development. People really don't care about the transcripts. They want to get like, give me the 3 things I have to improve in my contact center. They should be more or less reliable, but I want to have those 3 things. And then there are users like me who would, no, I don't want to have 3 things. I want to get the data and want to do analysis myself. But yeah, product development and onboarding.
So for our case, we don't really have customers. We do have people on GitHub accepting free labor. So we do get like funny comments like, basically this Pixit work, it's the first version, we only train it on like English meeting data sets. And we get questions about why doesn't this work on Mandarin TV shows? What's going on? So yeah, so far I've tried to be patient with them, but maybe I need to like generate some automatic sort of response.
So yeah, I mean, I think we're looking at this a little bit wrongly. Customers are not the problem. Customers are opportunity. But I think in our case, especially considering where I work at, so people come to my team specific solutions when they have problems, right? So I think the key there is actually to provide consistency in a way, because if they only come to you when your problem is, if you don't manage to solve their problem that time, you don't manage to do it twice, you will lose the customer at some point. So if we are able to consistently give them good experience, and this is, it does its work for itself.
Okay, thank you. We have quite a short panel, so let me maybe offer a chance to the public to ask either anybody in particular or the whole panel. Now's your chance. Please, just wait for the mic.
Hi. So this is a bit of a specific question to Risto, but you mentioned that your customers often don't have GPU, so you want to like serve inference on some kind of non GPU accelerated hardware. But on the other hand, it seems like your customers are big companies, and and it didn't seem like it would be some kind of situation where you want to do this on a drone or something. So they would probably actually have the resources for that compute. So, like to the extent that you're comfortable with disclosing, like what can you say about this serving this optimized inference on like CPUs and like yeah, just describe a bit this.
Well, basically, our customers are big companies, but investing in improvement of customer service or contact center is not probably a priority. It's usually the first place where they try to cut something when they have budget constraints, which is very common. And this is also a reason why they don't want to have a GPU clusters to do some transcriptions, because, well, it's not so sexy then to say that we have, I don't know, maybe chatbot, and then, okay, maybe we need our own LLM. On the other hand, I wouldn't say it's a big problem for us, because when we started doing ASR 6-7 years ago, I think, we were already doing that on CPU then. The frameworks were, I would say, like ancient compared to what we have now, but they were efficient, and also which meant that we couldn't just rely on that. We have a huge amount of data. We need to have some kind of knowledge how the models work, how to make the models smaller, how to generate your self-training data, which is something that as you have this knowledge, you see that, oh yeah, you can, I don't know, distill the models, you can quantize a model, maybe you can use some frameworks or something that is not so common, but somebody's researching, and it's very, very efficient. So it means that you can't just use Google that, hey, give me state-of-the-art ASR model, but you really have to kind of know where to search for.
If I can just hijack the opportunity to for that question, sign.mt started as like an open source project. There is browser.mt, which you might be familiar with. That's a project that was aiming to do machine translation in the browser. And I was so excited about it. I was like, this is a really sick domain name. Sign.mt stands for sign machine translation. Let's do everything in the browser. So we have no costs, right? No user cost. There can be 100,000 users, and that should be fine. With the years, so the project exists for now 4 years. With the years, we see that cloud compute is becoming cheaper. Models are running faster. Inference is becoming, to some extent, free on cloud. And so for us, we're actually seeing some kind of shift from browser first or user client side first to just inference on the cloud. It's very, very cheap for us. I don't know what scale would require the need, to make it CPU first on the device of the user.
Thank you.
I would say that this GPU, it's getting more easier now as this generative AI has gained a lot of traction. Because if you don't have a chatbot or you're not using LLM, then you're like left behind somewhere, and everyone wants to have that. And which also, as we have like this information security certificate, before generative AI, they said that no, you can't use any connection to outside world, no outside services. Now, okay, we can use Azure because we are on this platform. And it might be maybe in near future that we say that, okay, if you want to have a really good transcript very fast, provide CPU and GPU, and it's not a problem. For me, if there would be a public model that would solve my problems, I would use that. I wouldn't do myself.
All right, let me take this into another direction. I seem to be focusing on the people more than AI models, but you represent today 4 quite different directions or domains in AI. If you think about education,
4 white people.
yeah. if you think about the current education, so you're hiring somebody who has a bachelor's in, I don't know, IT or data science. How long does it take a person to learn your area? So how much training you would expect an engineer to be ready, or how ready are the people when they're let out of the universities, in your personal experience, to do what you're doing?
My personal experience, it might be depending on the tasks, couple of weeks to a couple of months. Usually not so difficult if you already know like how the models and stuff work. Then I can show you what we are doing, how we are doing, and it's not so complex. Of course, if you want to like develop yourself and lead the way, then it's taking a bit of more time. But really, it depends on a domain and what kind of what kind of level do they have to do? Do they have to like replicate what we're doing, or you have to like do the research and provide yourself a new ways how to do things even better?
Well, obviously, researching and updating will take longer.
Yes.
But weeks and months sounds like a short time. So are you talking about simpler tasks, or are you complementing the nowadays education?
I mean, I'm talking about like they are like capable of doing stuff that we are already doing on a level that we accept them or expecting them to do. Of course, what is difficult part kind of is not the technical challenges, but it's more like also we are like a small team is this kind of a product development. What should be the next task or next research task? Because there's so much that we could do, improve, and setting the direction. And this is what I would say something that you need more experience to understand what is important and what is not so important.
Okay.
For multi-talker speech processing, as I said, the tasks are pretty separate at the moment. So I think if you only focused on one task, it would also be quite quick. But because the approaches are pretty different, I think like becoming completely familiar might take longer. But if we do move to this like more joint training approach, then I think it'll be easier for people to get up to date.
So yeah, I mean, we kind of have two different approaches on hiring people. So depending on the level, so if you're looking for somebody that is already senior level or staff level, those requirements can be quite high, and we hope that you already have this experience in this specific area you would be working in. But also, like usually how we hire is that we don't care too much about you having the specific skills. We tend to hire, especially in AI, more generalists, because it's really hard to find people that have these specific skill sets, have your basics, know your basics. So we see quite often that people don't even know how decision trees work, logistic regression works. They don't know basic probability theory. So make sure that you have your baselines covered. But what say is like when people join the team, I guess like first 3 months is usually like, okay, when people are actually starting to provide more value, but to get the full up speed, it may take like year plus to be like, yeah, I know everything about my domain. Those are the potential areas to go to. And this is where I can provide this maximum value.
Okay. Amit, did you want to?
Sure, I'll also comment on that. I don't have that much experience with hiring just after graduation. However, I do supervise many master theses of master students. If they come from a computational computer science background, I feel like as long as the project is somewhat well defined, or as long as we know what they want to work on, they excel immediately. If they are computational linguistics master students, at least in the University of Zurich, we are struggling to get them on board. Like that's my experience and other professors there. I would say that from a 2-semester thesis, which is the default, it takes a semester to just get them to understand the tooling.
Nice. Dear audience, let's give you the chance to ask as well. Silver?
Do you know the names of everyone here?
I probably need to meet a couple of people still.
All right.
Yeah, thank you, guys. I guess a question for Joonas from TalTech and Risto. So what do you see as the main obstacle right now for wider adoption of ASR systems in Estonian public in general? And what would be your solution to get past these obstacles?
So the question was, what are the main obstacles for like widespread adaptation? Yeah, I haven't. I guess Tanel has worked more on like applying TSR systems, but I think usually we have this project with Parliament, and I think it still requires quite a lot of hands-on work, and we don't have that many resources in our lab to sort of dedicate to the industry projects at the moment. So I think more people would help. Maybe yeah, better documentation so that people are able to sort of take these open source ASR systems we've developed, like integrate themselves and like not need that much attention, assistance. But I mean that also needs like resources to generate those documentation. So it's tricky.
Yeah, I remember we used the help of Tanel when we started doing ASR models. So that I think one of the things is if you want to set up something that is publicly available, which is already pretty good stuff, you kind of have to have some kind of technical knowledge or background. I think if there would be some service like you can do no click or like 2 clicks and have a chat bot already running, if it's something like also put this ASR model up and running in 2 clicks and everything is working, then I think that might help to spread it. Because now it's like, yeah, I know I can do that, but I don't have time and I don't want to think about that, how to set it up.
Okay, hopefully Silver's question got addressed. Anybody else? We have some time. If not, then at least let me go with one last one, because, well, when we came up with the name for the seminar, it was text and what's next. So to include all other modalities, and currently I think mostly each one of you focuses on, well, if not one modality, then at least one particular task. So do you yourselves see this as multimodal, combining text and motion and video, or bridging text and speech? Not so much text, I guess, in case of speaker identification, but lots of text and bridging it with the users. And also, do you see, so now it's not like text level AI is solved, but it's been properly addressed by the development of LLMs. Do you see the area you talked about today not really disappear, but get a huge boost by some multimodal LLM or VLM or something appearing and suddenly handling all of that? If not perfectly, then you know how ChatGPT doesn't give you perfect answers. It gets you 80% of quality, and you actually have to make an effort to get it to 100, but still you get 80 for quite cheaply.
I think one of the things that this kind of things allowed to do is like go on a next level of abstraction. So now you don't focus on getting all the words correctly because ASR is pretty good. You don't focus on having good summaries of the phone calls because now ChatGPT can do it like pretty well, even if the transcript is not so good anymore. Now you can go on the next level and from our perspective, like asking the real business-wise questions, like what the salespeople have to do to sell those things more, or what we have to do to get rid of those phone calls that don't produce any value to the company. And this might be maybe a tabular data, maybe something else that is already giving you real kind of insight from there. And for us, it's like a one big stack starting from this phone call signal that is noisy up to having transcript and up to the business value. And it kind of have to like work together. And if one of the parts is missing, then it's not useful for our customers anyway.
Okay.
From the perspective in sign language, I can say that existing models suck. Like there are vision language models. You can put stuff in Gemini and it will understand video to some extent, or you can tell Sora generate video and it will do it to some extent. If you give it sign language video, it will not be able to translate. If you give it a text and ask Sora to generate sign language, it will not be able to translate correctly. However, we did find that if you now give Sora not the translate this sentence to sign language, but perform this sequence of movements with your hands and your eyes and your face and whatever, all of a sudden it's able to actually perform. And it's performing decently well. Same on the other direction. If we give a video to Gemini, in this case, Gemini 2.0 Pro, it is able to describe what a user is doing, what a person is doing, not what the meaning is. And there, if you remember from my talk, we're talking about sign writing. It's allowing us to basically write the phonemes produced by a user. If we describe these phonemes, if we have one more layer on top of it, which is our sign writing description project, and we describe the phonemes, the model is able to produce the video, and vice versa. And so the increase of these models in video understanding and video generation helps us a lot, at least in either creating one more pipeline step or generating synthetic data. We're able to generate sequences of phonemes, ask Sora to generate a video for these phonemes, and it does pretty well. And that can be used as pre-training data for models. I don't think that for the immediate future, we are seeing these multimodal models also solving sign language, just because there's no data. But once we're able to generate data synthetically, all of a sudden, these models would also understand, in my opinion, meaning. It will just take a few more years, and we need to do the hard work of the pipelining right now to be able to create and allow these models to have all of the data that they need to actually understand.
Okay, thanks. What about splitting the speaker signals or getting an LLM actually to answer to both customers without us having to prompt it?
Sure. So there is a lot of work being done integrating speech processing into LLMs as sort of a module that takes it into the same latent space, I guess. But as far as I know, it hasn't shown like a sort of a dramatic improvement in performance in any of the tasks yet. I think it's mostly been also focusing on single speaker scenarios so far. So it might happen as we as this is explored further. But I think one thing for the tasks that I discussed is that the difficulty sort of jumps up by an order of magnitude as you like increase the resolution. So I think the cocktail party problem probably will remain unsolved for a while at least. And also there's a question of computation resources. Like a lot of these models, you want to be quite lightweight, but if you these like multi-model approaches are pretty computation heavy, so might not work always.
Okay, Joonas, do you want to comment?
I mean, there's not much. We don't do much multimodal stuff per se ourselves. There is value, definitely, like having a voice interface for certain participants in the market. So drivers wouldn't have to use hands to create tickets, or couriers wouldn't have to use hands because they are busy doing real life movements, and even like making this kind of actions can be dangerous at times. So in that sense, yes. But in general, I'm a huge believer that video and other data, it really helps to bring LLMs to the next level anyways. So it's a huge throw of data, especially like considering maybe even like learning more of physics from videos, like human videos. So this can be like quite interesting for me.
All right. So by now as the main conductor of the event, I've done a tremendous job of missing all the ending, the timelines and schedules and so on. But let's mainly thank our today's panelists and presenters because they kept their time perfectly, and also for their presentations. And same goes for Agnes. And this is where we finish the sitting and listening part, but let me also advertise that the 41st Data Science Seminar will happen on May 21st, and that will carry the title of Decoding Humans, How Data Drives Human-Centric Solutions. So, thank you everybody once again, and networking and snacks and drinks are still waiting for you, and so the event is not ending yet. Thank you.